So yes, it's cool to be here. My name is Joe Grand. I recognize some of you and don't recognize most of you. So thank you for having me, and to Aaron and Crystal, of course, and the whole team for inviting me out here. You might kind of be wondering, I mean, Aaron kind of spoiled it a little bit, but you might be wondering, like, why is a hardware hacker here if we're talking about, memory forensics and this sort of thing? So back in 2000 to 2003, I worked on a project at a company called At Stake, which is one of the first computer security consulting companies, with my friend Brian Carrier, who also is now SleuthKit Labs, right? Yeah, so Autopsy and SleuthKit, all of that stuff. So we'd worked on this project of building up hardware to do hardware imaging of live computer systems over PCI Express, PCI actually at the time. And we were sort of thinking, oh, we could use this in situations if there was some sort of attack against a device. You'd put these in important servers and extract all the information. So this was our proof of concept. And I guess it was pretty ahead of its time because nobody was really thinking about volatile memory acquisition. It was all about hard drives and sort of static stuff. So this was sort of the start, and we didn't end up doing anything with it because every single person was like, I don't want to put hardware in our servers. We're not going to get attacked, blah, blah, blah. Of course, now everybody's getting attacked, and it probably would be relevant maybe in a modified version. So actually, Joe Fitzpatrick later today in the afternoon is talking about a project he's been working on that is an open source little tiny PCI Express module that really is a continuation, I think, of all of this stuff. So pretty wild. So that is my little memory forensic connection. And this is the output. So we were running our little Tribble station on a PC, and then we had like hyperterminal and all this stuff open, and then this is showing like we could actually dump the volatile RAM. So it was kind of fun. It was like these early days in kind of even forensics in general, like pretty cool. But what I'm going to talk about now is sort of my adventures of what I call wallet hacking. And Aaron mentioned it. Like I've been involved recently in helping people recover cryptocurrency from mostly hardware wallets, also software wallets. But I want to preface, like, how many of you sort of do cryptocurrency, like maybe forensic cryptocurrency tracking? Yeah, a couple people. Anybody invest with cryptocurrency? Invest, I'll put in quotes. Yeah, a couple people. Okay, so I want to preface this, like, I don't own cryptocurrency. I am not involved in the cryptocurrency community. I just like using my skills currently to help people get access to their devices. And this is not that much different than any other sort of memory forensics. We're trying to get not volatile memory, but we're trying to get static contents fixed in memory out of devices, whether they're physically locked on a chip or from a hard drive or a phone or whatever it is. So it's fun to sort of use these same skills in this situation, and some of this we've documented as videos, and this one in particular is sort of what started this whole thing off. So this guy had emailed me a couple years ago and was like, hey, I have $2 million locked on this Trezor One hardware wallet, which is like a hardware wallet that stores the recovery seed in your PIN and will sign transactions and stuff. He's like, I can't get to the funds. I had already known some friends of mine had done some work on the chip running on these devices and proved, yes, we could do a technique called fault injection that basically you're intentionally causing the chip to fail at a certain point in time while it's running to bypass security checks and a bunch of other stuff you could do. But in this case, bypassing security of this chip to get access to data on it. And that work was already out there. So I'm like, all right, how hard would it be to like replicate their work? So I accepted this guy's, this guy's email was well written. I'm like, oh, this is cool. So I kind of talked to him, accepted the project, and then started down this path of basically learning this technique, which I'd wanted to learn for a while, but now I had a reason to do it because this guy had $2 million and I was going to get a cut of it. So there's always the financial motivation also was there, but the curiosity for sure. And so I basically spent 3 months kind of learning about fault injection and trying to replicate their work. And then I very quickly realized that there's a big difference between kind of proving an attack works, proving it once to give a talk at a conference, and then doing it in such a way where you're basically, you're working with the crime scene. You can't mess things up, right? You want to limit that risk as much as possible. And if you're trying to get contents out of memory and your technique erases the memory, now you've lost the information. So it was a very hard process to get from like proving it could be done to doing it in a repeatable, reliable way. And it was super stressful. But eventually figured it out. And this particular version of code running on this particular version of chip had a problem with the way it was storing the private key, the recovery seed and the pin, really. And I like this because it's actually a great example, because this code, when this device was loading up, it was copying this protected information into RAM. So everyone should say, yay, memory forensics. Like, there's data sitting in RAM that shouldn't be in RAM. I don't know why the private key should be in RAM. You probably see that all the time if there's some sort of encryption thing happening and something goes there. So there was basically, I don't know what the reason was. It was some sort of oversight or whatever, maybe for speed purposes. But the contents were copied into RAM every time you powered the board. So with this particular chip, there's basically a bunch of different levels of security. And if I could defeat the first level of security, I could actually get debug access to the chip, which would let me kind of manipulate things, but only get access to RAM, not to flash memory. Because ideally, I would get access to flash memory, just get all the contents out and be done. But because of this bug, all I had to do is get access to RAM, and then from there, use my debugger to get the contents out of RAM. So this is what kicked off this whole like wallet hacking thing. And I'm going to come back to this project at the end, which has now been 3 years, to sort of see where things have progressed. But this was really the beginning. So basically, this was my setup at the time. So this was a couple years ago. And I think it looks pretty cool. This is a device called the Chip Whisperer. So this is something that helps you with voltage glitching. So basically doing, like, turning off the power really quickly to cause that fault injection. And also lets you do what's called side channel power analysis, where you can kind of measure unintentional leakage of a chip and then use that to your advantage, say, as a trigger to then know when you want to perform your glitch. So very, very cool. And this was started by a friend of mine during his PhD work of like, I want to study side channels. And then he ended up making these products that have made this type of technique that used to be you'd have to like craft your own stuff, now very common. Still difficult, but very common. So the accessibility of these tools, now basically anybody that's learning fault injection, like you can basically just use it as a hammer and like hammer any chip, because most chips don't have any mitigation. So it's pretty powerful. So yeah, Chip Whisperer. Then I have my target board that I had to modify to get ready for voltage fault injection. Up at the top is a debugger, basically to let me connect to this debug interface. Just like, does anybody use GDB, to debug some software application or any other debugger? This lets us do it for hardware that has support for debugging. And then I have another device that I'm basically power cycling the unit. So with a lot of research and based on some of the earlier research from my friends, I knew like, okay, at some point after this point in power up, I have to wait 170 microseconds. And at that point, I'm going to turn the power off really quickly. And then if I'm lucky, I will succeed. If I'm not lucky, I power cycle the board and I do it over and over and over again. It's kind of like how some early mod chips worked, where you're kind of putting them on in your game console and it's basically trying to defeat security over and over again. Same sort of thing. So this is, for me, a very important thing of like, I'm looking at my voltage glitch as I'm like powering the chip down. And then you can see, you can see like I'm doing it over and over, and it's kind of slow, but I'm using my oscilloscope to be able to visualize the signal and what's going on. And here's my Jupyter notebook. So even though I'm a hardware guy, I still occasionally write code. Nothing that I would really like show off to people, but to get hardware working, you also have to write code. And this is one of the situations. So I'm basically, trying over and over and over and over again. It's saying no, no debug interface, no debug interface. Fault injection, not working, not working, not working. Then all of a sudden it's like, yes, it works. And now I can connect with OpenOCD, communicate to the device, get the RAM out of the device. So this was like a huge moment after 3 months of work. And I eventually, showed it to the guy that was going to fly to my house from New Jersey. I live in Portland, the other one on the West Coast. And proved that I could do it with a couple different devices. So he flew over and we did it on his device, and we could actually like, once we got the RAM, we could get his pin, we got his recovery seed and everything, and it was very exciting, and he was very happy about it. And this project, I was just going to do on my own, and my wife was like, you should really be filming this. Like, you should show people that you're still a hacker. I was like, okay. She was totally right, because a lot of what I'd been doing at that time was like engineering-related stuff, and I'd been making some open source hardware tools, but it just, I hadn't had a video in a while. And definitely hadn't had a video like this, which basically was like its own little TV show. So this video went viral. And based on that, we're like, well, if this guy needed help with recovering cryptocurrency, like there's probably tons of other people. And that is what has taken over a lot of my time since then. Sometimes it's fun, sometimes it's not fun, and these are some of the stories kind of related. And also, the reason I'm giving this talk I thought was kind of cool because here at the conference we have like the makers track and the hunters track, and this is sort of a combination of both, where sometimes I'm making my own tools, and sometimes I'm using those to hunt, and sometimes I'm using other people's tools to hunt for stuff. But it's all looking for information in memory. So yeah, this was fun learning about fault injection. I'll come back to this at the end. Anybody remember this phone? Samsung Galaxy G S3, I think it is. So this was another very early one. After the video came out, we got hundreds of emails a day for a while of like all these mostly crazy people. Is this going on the internet? All right, I won't get into that then. I could write a book about the types of emails we got, especially those who are into cryptocurrency. Like I thought, because of my first connection to it, which was this guy who was an entrepreneur and he'd been around for a long time and technical, I thought everybody involved in cryptocurrency was technical. But it turns out there are some, but you have a lot of people that are sort of going for the get rich quick kind of mentality, and that's a totally different thing. But we didn't know that at the time. So we were very like, yes, let's keep going. So we had a guy contact us, super cool guy, who had this old phone, and he had bought some cryptocurrency on it. Back at the time, he was like, I had to go to Starbucks and meet a dude at the corner and gave him some money, and he put some crypto on the wallet. I'm pretty sure it's on my phone. And he's like, then I had a kid, and I threw the phone in a shoebox and forgot about it. And then, 10 years later, he's like, as Bitcoin goes up, he's like, oh my God, I could be a multimillionaire. So he emails us, and he thought he had 30 million on it. Based on what he told us, we calculated it was maybe 6 to 15 million, I think. So we decided to take on the project. This is sort of an old school forensic acquisition project also. So we decided, he had a PIN, the swipe pattern, the gesture to get access to his device. It turns out that you can actually, if you can get the contents of the phone, you can find the swipe pattern, which is stored in like some sort of hash thing. And there's like table lookups that you can, or rainbow tables that you can like get the hash so you know the pattern of what it's supposed to be. That's like a common sort of like digital forensic thing for Android phones at the time. So I did some testing, and it turns out with this version of Android phone, there's actually a connector on the left side that was the JTAG interface. And that's an industry standard debug interface, but very, very powerful. If you can get access to that, you can generally control the phone, sort of like root access for hardware. And through JTAG, there are some tools written by various groups, usually in China, but other places as well, that work with specific tools, specific phones, mostly for unbricking, but also for memory extraction. So I tested it on a test phone, got my debugger connected. Some places even make JTAG adapters that connect onto the connector on the phone, like super easy, right? I was like, this is gonna be a piece of cake. So this particular guy didn't come to my house, which actually turned out to be a really bad precedent. If you don't want people coming to your house, don't make videos of people coming to your house. Because after that first video, everybody wanted to come over and watch me hack. And I don't know if anybody's ever watched you hack things, but it's like, watch the monkey do the work. So it's very tricky. And of course, because we're making videos, people have to come to my house, and it's been like, I've kind of gotten used to it, but not really. But so this guy was a little paranoid. He didn't want to come to the house. And he was in Seattle, which is like a couple hours drive from Portland. We're like, all right, we'll go to you. And he drove a bus for the city, like very tight schedule, so he didn't really have a lot of time. So we ended up kind of moving my lab to a hotel in Seattle, drove everything up, set it up. I have a microscope here looking down, kind of got everything ready for worst case scenario of like, what if the phone doesn't have the connector like I had on my test phone? What if something doesn't work? So I brought everything, expecting the worst, and kind of got the worst. This was a picture from the video. So this was our second video that we made, by the way, about the wallet hacking stuff. So there was a connector on the phone, but when I plugged in my hardware for it, it wasn't actually working. It wasn't detecting the JTAG interface. I was like, oh my God, is there a different version of firmware? Like, did it disable it? What's going on? So then I was like, we have two options. One of them is we could solder wires to the connector to give us like a hardwired connection, and then I can bring that out to my circuitry. Or we could access the eMMC memory, which is a type of memory, flash memory, fairly easy to access. There are some test points on the board. We could get to it. If we could get eMMC access, plug that into our computer, we could mount it like a file system, run DD, do all of our standard software forensic stuff on it. But that was a little more risky because there's some coating on the board to protect against like moisture and corrosion and stuff. So we would have to break through that first with little tiny needles to touch down. There was just a risk of damaging the hardware. So LeVar, the guy whose phone it was, decided like, let's do the soldering first. If that doesn't work, then let's go to try to get the memory directly. So this is what it ended up being. I don't know if you've ever tried to do micro soldering in a hotel room with bad lighting and a camera. Not recommended. And even during the video, I'm like, the internet is going to make fun of me for this because they're, the internet makes fun of everybody anyway. But it's like, you should have used a smaller soldering iron tip, or where's his blah, blah, blah. So even in the video, LeVar is like, if you haven't tried this, like, don't talk about it unless you've done it. So we were successful in soldering and finally got the device to connect. And we're like, yes, now we can start sucking out all the memory from the device. And we miscalculated how long that was going to take. This was 16 gigs, I think. Yeah, 16 gigs. The one partition we needed, it was like 14, whatever. So a huge device. And with JTAG, it's a serial interface. So you're doing things relatively slowly and totally miscalculated. It ended up taking 20 hours, but we only got the hotel room for one day. And we're like, crap. So, and the hotel room was like being used by somebody next. So we kept going to the hotel staff, like trying to extend the stay as long as we could. And eventually they're like, you just have to move to another room. So they got a room next door. But anyway, you'll see what happens if you watch the video. We eventually were able to get the data. So excited. We go into the other room. We start analyzing the data. We find the swipe code. And then you want to see what was on it? I don't know if you can see it from here, but it was 0.003 Bitcoin, which at the time was probably, I think, like $1,000. So this was my first disappointment of like, damn, this is like, people don't always remember what they say they remember. It's a different kind of memory forensics, right? Like, it's the human brain. And man, people are wrong almost always. So as we were filming it, like LeVar basically got all sweaty and he was like, oh my God, I'm so sorry. And like, he actually had to take a walk to calm down. And I was like, I'm never going to see him again. But he did come back. He felt so bad. And he was, a millionaire in his head until we did this. So I kind of crushed his dreams. Most of the money, it turns out he didn't buy nearly as much as he thought. But we did find the text message logs of like him arranging the meeting with this guy. But some of it went into like a Bitcoin blender sort of thing. Some was like, I think he bought some weed or something online, and basically moved some to an exchange. That exchange went away, and there was like nothing on the phone. So we did end up getting more money than he put in, but it was a real lesson in like, okay, maybe memory not so great. Okay, this one. Talking about interesting people. This one is a Ledger Nano S. So Ledger is a different company than Trezor, sort of a competitor for hardware wallets. And Ledger's designs are much different. So the Trezors use a general purpose microcontroller called an STM32F2. And they also have for the Model T STM32F4. And they have newer versions of devices now that are similar to Ledger. But at the time, Ledger was the only one that used a type of component called a secure element. So instead of a general purpose microcontroller or just like unprotected memory to store data, secure elements actually have security features and anti-tamper mechanisms and fault injection mitigations and things that make it way harder to hack on. So this guy came to me and said, I have a Ledger, I know the pin, but I threw the device into water for testing and then it fell to the bottom of the lake and I couldn't get it out for 7 months. And he was in Florida, there's like those little lakes and stuff all over the housing communities and stuff. I'm like, what? You threw it in water for testing, and there was money on it. So I don't know. It was a little bit strange. Yeah, he said he was performing a test for durability and security reasons. I think somebody probably came to the house and he's like, shit, and threw it in the water. He had to hire a dive team, a professional dive team, search and rescue to get it out of like the muck at the bottom. And he had it. And I was like, don't plug it in. We don't know if there's moisture in it. Like, is it corroded or whatever? So I did some research, and I was like, if we can preserve some of the chips, we can do a cool kind of memory swap take it, kind of take a donor board, take the important stuff, put it on another thing. This is the block diagram of that Nano S. They've changed things for later versions of their ledger, but we're also looking into those. But this one in particular, we had the microcontroller that sort of handled the display and the buttons and kind of the user interface stuff, and then all the secure contents were in the secure element, and there was some communication happening between them. But it turns out if you just take a brand new one, take a secure element from a different unit, plop it in, it will work because the communication, like the API, the communication structure and everything is the same. So the swap, I thought was a pretty good idea and tried it on my own device and it worked. So really it just came down to like, can we swap the chip and hope that the chip hasn't been damaged? This is what the device looks like inside. That's the secure element. So just an 8-pin device. But looking at it, it looks like there's kind of solder along here, but really the connections are pads underneath the chip. And there's a little bit of solder coming up on the edge, but basically to desolder this, you have to use a technique called hot air, or you might have heard of like chip off to take a physical chip off the board. So I had to use hot air to take the chip off instead of other techniques that would be lower temperature. So there was a little bit of risk in doing this work, especially because chips absorb moisture over time, and because the plastic packaging and moisture gets in there. The fact that it had been sitting in a lake or whatever, water for 7 months made me extra concerned. Like there was definitely moisture in those chips. So I wasn't just gonna go put hot air on it because if you increase the temperature of a device that has moisture in it, the moisture is gonna expand and then it could crack the die, it could crack the wire bonds, it could cause damage to it. And that's called popcorning because same thing like you cook popcorn in the microwave or whatever and it expands and it pops, except in that case you want it to pop. In case of chips, you don't want it to pop. So you need a way to like get the moisture out of the device. So I bought myself a gift, sort of a Christmas miracle that it showed up on the rare snow in Portland. This is what's called a drying oven. So it's an oven specifically designed to like get set up for a very precise temperature. I think it's for like biology and for drying, even for 3D printing, it's great. You can like dry filament. And I was using it to extract the moisture from the chips. And there's even like an industry standard around like how long do you run it at what temperature for certain thickness chips. So I ran it basically 125 degrees C for 48 hours, which was overkill, but I wanted to be sure. And when I did open the board, by the way, it was totally it was like, there was like crap all over it. Like it was disgusting. So cleaned that up, put it in the oven, baked it, removed the chip. And here you can see the chip is off the board now. And also what made it tricky is there's this thing called the exposed pad, which is a big blob of solder underneath the chip, basically to give it a good kind of ground connection. So I had to have the heat to be able to make that solder molten as well to get the chip off. So I got the chip off, but the cool thing is I don't need to reconnect that middle pad. I can just hand solder the 4 on each side with just big solder blobs and hope that it makes a connection to the metal underneath. And it did. So I could solder the chip, his chip from his old device to a new device, and I could get the device to power on, and then I entered his PIN, and we could get access to his Bitcoin, and it was pretty cool. I had done one recently. So is this going on the internet? You don't know. Aaron, is this going on the internet? We don't know. It can be edited. Okay. Well, so there's another one that we did recently. It's probably going to be in the next set of videos that will probably come out in January. But I did a swap for somebody else because when I opened up his device, which he said also didn't work, this guy, when he plugged it in his computer, it like wasn't being recognized. But because it was a Ledger Nano S, I'm like, I know this problem. I could take the chip and put it on another one. When I opened up his device, there were like components missing and somebody had like stabbed one of the chips. And I'm like, somebody sabotaged this, I think. Oh, maybe I shouldn't give it away. Well, I'm going to give it away, whatever. So I ended up doing the swap, plugging the device in, and now the device worked because I had repaired it, but it turns out that the contents were wiped. So it's like, did somebody like steal the money and then wipe the device and try to sabotage it and then gave it to this guy? Like, it's a mystery. But seeing his face, like we record a lot of this stuff, and his face was like shock. Which is the reality of this sort of thing. So this one is a fun kind of software reverse engineering one. This also became a video. This was against a tool called RoboForm, which is one of the early password generators, actually based somewhere in DC. Is anybody here from RoboForm? Cyber Systems? Okay. I imagine you probably won't raise your hand anyway. So this was a early password generator, still used today. Now we have all sorts of other password generators. And this one, you set your configuration of what parameters you want, and you press generate password. You get some sort of randomly generated password that you can use, which is great for all sorts of reasons, especially because things get hacked all the time, and it's like password reuse, as we know, is a big problem. This way, you have different passwords. I like it because there's this plausible deniability of like, if somebody ever asks me like, what's your Google password? I'm like, I don't know. So they can't compel me to give up the password. They could compel me to maybe give up my master password for everything, but I'm not going to tell them. So this one, there was a guy that set up his Bitcoin, and he could actually prove what he had. So he had like his public address. So we knew the amount that he had. He said he had generated a password using RoboForm and then used that to encrypt his wallet file. And then he forgot his password. And most of the time, if somebody's using a password generator, you're not going to be able to brute force a 20-character PIN with special characters, blah, blah, blah. I mean, maybe some of you in here, depending on where you work. But for normal people like us, that wasn't computationally feasible. And I remember he emailed me, and I'm like, we're just not going to do it. It's not going to work unless there's a bug in the software. And we kind of forgot about it for a year. He contacted us again, and I'm like, all right, let's do a software project. Like, this will be fun. I complain a lot about like doing hardware hacking is you can't just like bring your laptop somewhere and set up and like start hacking. You need like a whole thing. So this was fun of like being able to sit just with a computer and not need any other hardware. So we started looking into RoboForm, and we found in the changelog at one point, June 2015, they had a note in their changelog, password generator, increase randomness of generated passwords. Huh. We're like, okay. And it turns out that the guy had generated his password in 2013. So we're like, does that mean that these aren't actually random? And there was no other information about this at all. So we start digging into the code, and we're using Ghidra to do some static analysis. And it took us a while to get to this point, but we find the password generation routine, and we see this. Does this seem bad? If you can't see it, we're calling system time, but that's not the worst part. Probably the worst part. Oh, then we're doing some preparation on it, whatever, doesn't matter. The worst part is this. Can you see that? It's calling srand. So we're seeding the pseudo-random number generator with time. No, don't do that. This is like the first thing you learn with secure coding, right? Of like what not to do. Don't use time because you can go back in time and regenerate everything that had been done. And that's what we did. So we saw this, we're like, awesome. Then we did some tests. We used a program called Cheat Engine, which I guess is kind of, I wouldn't say like soft ice, but you can actually see inside of volatile memory as the program's running, and people use it to like cheat on games on the PC. So we used it to make sure that the password was actually being stored in memory somewhere, because if it was, then we could basically generate those, grab the password, and start making a list, like pre-compute everything that came out of that password generator. So yeah, it does some post-computation as well, but irrelevant. Then we started doing some live debugging. Once we kind of knew the area that we were interested in, and here, we basically verified that we knew whatever address was coming out of EAX after a certain point, that was pointing to the password that was just generated. So now I knew, okay, I can figure out a way to wrap around this password function, grab EAX, store that in a file, change time, do it over and over and over again. And being a hardware person, that seemed to make sense. Like some software people are like, well, you could just extract this portion of code and then execute that on your own. But it wasn't that simple because there was like all these different calls to all sorts of things. There was a DLL that was loaded, and like it didn't seem to, it was just way too complicated. So I figured let's just make a wrapper that's going to hook right into that function call, get the data out, and get it back. So it ended up being pretty slow, but that's okay. So I ended up writing some code. This was actually the first time that I had used ChatGPT. And I was like, this is amazing. So it was like, how do I find a function within the DLL? And it's like, here's how you find a function within the DLL. And there was like some errors with it, but I really liked it because I hadn't done any sort of like low-level assembly in a while. But being a hardware kind of embedded systems engineer, you're dealing with assembly language a lot. So it was nice to do that, and ended up writing a bunch of stuff. Once you hook in, you have to set the registers to the right thing, get everything ready, and then you can get the password back, and then do it again and again, basically changing the parameters, changing the time, and making a big list. So this is like running my code, and here I'm taking a time range that we had thought the guy had generated his password in, and then basically pre-computing the password given the parameters that he thought they were at that point in time. And you can even see down at the bottom, the system time is increasing every minute. And we're doing like 100 a second or something. So 100, I think it was 100, I don't know, it was slow. 100 passwords per second, which doesn't make sense because that's not really 100. It was slow. Because we're writing it to the console. Yeah, so if we're writing to a text file, it's a little bit faster. But it was fine because our memory range was like a couple months. He thought he had 20 characters, uppercase, lowercase, numbers, whatever. So we did this, and ultimately, and then used these passwords to try to brute force with this password list the password protected wallet file. And this one we succeeded. And then we decided to fly we flew to Spain because he's actually from Germany, but he was in Spain on like vacation or whatever. So we flew to Spain, set up this whole thing, and surprised him with this gigantic check, sort of like Publishers Clearinghouse style, which it turns out is not a thing in Europe. But I thought it was hilarious. And then we had to fly with the check. It was pretty wild. But we made it, and he succeeded. And there was some drama along with that too, because he was actually wrong with what parameters he used to create the password in the first place. But we just pre-computed more passwords until we found it. But pretty cool. And then we ended up also telling RoboForm about it, like, hey, you maybe knew that something was wrong, but you never informed the public about it. And there was like lots of people that were using the product at that point. And we're like, we found this vulnerability. We're going to make a video about it. Wired wrote about it. I think it was Wired or The Verge. I think it was Wired wrote about it. And they basically were like, oh, we fixed the problem. And then the journalist is like, how did you fix the problem? Crickets. So we don't know. Maybe the new versions are just more obfuscated than the old ones, but I would not be confident in using that tool. At least they didn't sue us, which is like also a common thing that security researchers have to deal with. But they didn't. And yeah, this was super exciting. And sometimes when we're recovering funds, like it's life-changing amounts of money for people. Sometimes it's not. This at the time was 1.6 million. Now it would have been like 4 million. He needed it somewhat, but sometimes we'll do something where it's like $10,000 and it's life-changing for somebody. So we've kind of done stuff, in the U.S. and all over the world. So there is that sort of satisfying component besides the thrill of like succeeding in the hack. It's like, all right, now we actually helped somebody. So then that gets us back to the first story, and this is 3 years later. I'm still hacking on the devices, and actually now I've hacked like 30 of these devices, and I'm working with a friend of mine, Lennart Wouters in Belgium, and he had contacted me after the video came out and was like, hey, I want to replicate your work. And I'm like, I don't know. It's like, I'm not that happy with it. Like it works, but it turns out that I just got really lucky that I was successful with the camera crew there and everything, because we did hack it live for that video. And I was like, I want to try to make it better. So 3 years go on, he like graduated, got a PhD, had a baby, and then like we are now moving to, or we had moved now to what's called electromagnetic fault injection. So instead of doing voltage glitching where we're manually changing the voltage, we're using a little electromagnetic probe and we're injecting electromagnetic fields into the chip, and the physical location matters, and we've kind of cleaned up the setup and everything, and we have a CNC platform so we can move around the chip and really fine-tune parameters. And now we basically have an attack that is irrelevant of the user code on top. So the original version, we were relying on the fact that Trezor moved the recovery seed into RAM. Now it doesn't matter. The STM32 F2 and the F4 series are susceptible where there's an internal bootloader in the chip that's hard-coded into the boot ROM, so they can't fix it. The only way they can fix the problem is if they respin the chip. There's a problem with the bootloader that we can basically, once we do the first downgrade, we can get access to the bootloader, do another attack to basically read chunks of memory, of flash memory, or RAM, but we don't want that anymore. We just want flash over and over and over again. Trezor ended up encrypting the contents, but it doesn't matter. No matter what they do in software, we can get the code out, and then we can brute force the pin, which is going to give us the encrypted recovery seed, and then we win. So this is just a video of like showing the process. This work will hopefully be out soon. hopefully, maybe in conjunction with the videos that come out that sort of documents not really the technical side as much as the personal stories, right? Because those also matter. Like when you're doing, forensic, some sort of forensic case or whatever, like there is always a personal connection in some way. I try to sort of ignore it until I succeed, hopefully. Knock on something wood. Like being a surgeon, right? It's like they're probably not thinking about, oh, this is Joe, he, blah, blah, blah. It's like, this is a thing that I'm operating on at that time. And that's what I think about. So it's trying to sort of separate the human from the hardware, but there is always a human connection. So telling those stories is pretty cool. And then I think I'll leave you with this picture. This is this is why we were filming the process. Is there anything like weird about this picture? There's a camera here, right? Like that's pretty strange. That guy. So this was a project. I'm definitely not going to spoil this one because this is going to be in the video. But there was a guy that, had a lot of money on his device and insisted on coming to the house and flew halfway around the world. And I was like, well, I don't know that guy. Like at this point in time, I've done this for a couple years. Now I'm extra paranoid about random people on the internet. So I was like, if he's coming to my house, which I also did not enjoy, as you know, I was like, if he's going to come to my house, I need some sort of security. What you don't see here behind the photo is my camera guy, one of my partners who's sort of entertaining the customer who's also there with his wife. So there was like, and my office is not that big, so there's all these people and lights and everything, and that's me actually hacking the device, not looking very happy. Very stressful. And then this is a guy that, ran security for us, and I was like, I just need some sort of security guy there. I was like, I told my guy who was arranging with him, like, he doesn't need a gun or anything like that. I just want him to look badass to stand there. And then he was like, if I'm going to dress up in all my gear, like, I have to have a gun. I can't not have a gun. I'm like, all right, this is America. Let's do it. So he, was armed, standing in my little office, and wanded us as we came into the office, all of us, to make sure, we could prove to the customer that I wasn't going to, like, rob him. A very exciting day, we'll say. And then we ordered donuts, and yeah, it was great. And he was happy about that too. You'll have to see the video, but it was definitely like a very kind of entertaining thing. And again, hopefully we're going to release this information soon, because for me, it's really, yes, the technical stuff is fun. Yes, helping people fun, but sharing information is more important, right? Especially with all the open source tools, like that's where I come from, of learning something and sharing it, and writing tools and sharing it, and using other people's tools to build on. Like that's the most important thing. So that's going to come soon. And I guess I will say, like, this just sort of showed kind of some of my examples, right? My adventures of I guess you could say forensics of, hardware extraction and software extraction. And there's always different methods of doing that. And you find the right one that's like the lowest risk, that gives you what you want. So yeah, those are my adventures. And I guess I would say, like, good luck on your adventures and enjoy the conference. And thank you.